Hey, what's up guys? Welcome back to my channel where I teach you how to code in Solidity and Ethereum. We are going to dive into the world of signed integers, also known as int. Signed integers are commonly used to represent signed numerical values, such as temperatures, pressure, or any other value that can be negative. This data type can store positive, negative, or zero values. In contrast to unsigned integers, or uints, that can store positive or zero values, as we saw in the previous video. So let's get into it. To declare a signed integer, we use a keyword int, which is the alias for int 256, like this. And in contrast to unsigned integers, it can store negative value as well. So we can declare as int, or we can declare as int with the size of the number of bits we are going to use to store the values. So it could be int 8, int 16, int 32, until int 256. The number after int tells how many bits the integers can store. So because a bit is a binary digit that can be 0 or 1, the more bits we have, the more values we can represent. For example, int 8 can store 8 bits, which means that it can represent 2 to the power of 8 or 256 different values. But since we want to have both negative or positive value, we split the range in half. So int 8 can go from minus 128 to 127. That is minus 1 times 2 to the power of 8 divided by 2, which is 128 minus 128, and 2 to the power of 8 divided by 2 minus 1, which is 127. And the minus 1 is because we have to count the value of 0. Let's see how we can declare an int8 variable in Solidity. So we declare int8 public, so anyone can see it in the blockchain, and a getter function automatically creates, and the value will be signed8 size. This is the name of the variable, 127. So this is the maximum value that uint can have. If we try to declare 128 for this variable, it will throw us that literal is too large to fit in an int8. So this is basically an overflow error. That means that this value is too big to fit in the number of bits we have. Yes. For example, if we try to assign 128. Similarly, if we try to assign a lower value than 128, like a minus 129, the compiler will throw us also, in this case, an underflow error. We review overflow and underflow errors in a previous video. Also, it's important to consider that if we do arithmetic operations with these integers, signed integers, we need to store the result of the arithmetic operations in bigger signed integer sizes. For example, if we do 2 for example, signed A size demo, and then we do, for example, this would be like 50, and then we try to store int 8. We do public, and then for result signed 8. If we do this, for example, we do signed 8 times signed A size demo, this will fail because we cannot store like a higher value than this, than minus 128. So we are already in the maximum. So always when we do arithmetic operations in two ints that are a particular size, we need to store the result of the arithmetic operation in a bigger size integer, like int 16, or we can do int, which is the alias of int 256, is the same. So in this case, we can store the result successfully because it will fit into the this value. Yes, so it won't do underflow and overflow. This is an important. So for the assignment, so you need to do basically arithmetic operations with specific int size values and store the values on bigger, basically on bigger size integers. This is the assignment. So if we compile this, for example, we go here and compile the int, it will say, okay, I can compile. And then if we deploy this contract, we cannot deploy, it will throw an error. And this is because we are not doing nothing with this contract, basically. This is the cost. So this is an example of operations with integers. I hope you understand, and see you in the next video.